we'll start with trigonometry right now. Now when you are doing trigonometry in limits, there is only one formula that you have to apply. We will write that formula first. Limit of x tends to 0, sin x upon x is equal to 1. Right? That's the first thing that you have to do. That is the first formula that you have. That means whenever you are doing trigonometry, all sums have to be solved using this particular formula only. Let's start with the sum. Now you have to remember that the angle in the numerator and the number in the denominator has to be same. Let's start with another color. Limit of x tends to 0, sin cube 4x upon x cube. Okay. Now the first thing that I could do is I could take cube common. So this is limit of x tends to 0. Let us take cube common. So this will be sin 4x upon x the whole cube. Right? Now the angle in the numerator is 4x. That means the number in the denominator should also be 4x. So I will divide by 4 so that I get a 4x. Now in reality, what am I doing? I am dividing by 4 cube. Since I am dividing by 4 cube, to keep the equation constant, I will multiply by 4 cube. Use the formula sin theta upon theta, or sin x upon x is 1. So this is going to be 1 cube into 4 cube, 16, 64. Answer is 64. Right? Let's see another sum. Limit of x tends to 0, 1 minus cos x upon x square. Now, there are two ways of solving this sum. Either I could solve this sum by using multiple submultiple formula, or I could solve this sum by using rationalization. Since you all are not very familiar with the formulas, I would advise you all to do this by rationalization. Fine, do we get this thing clear? Now, let's see this. I'm going to rationalize this. Limit of x tends to 0, 1 minus cos x upon x square, 1 plus cos x, I'm rationalizing the numerator people, 1 plus cos x. A minus b, a plus b is a square minus b square. So this is going to be 1 minus cos square x upon x square, 1 plus cos x. Limit of x tends to 0, 1 minus cos square theta is nothing but sin square theta upon x square, 1 plus cos x. What I will do is I will write this formula down here. We are using 1 minus cos square theta is sin square theta. Right? Now here I could say that limit of x tends to 0, sin x upon x the whole square into 1 upon 1 plus cos x. I have taken square term common between these two. Sin x upon x is 1. Since I am substituting the formula, I need not write the limit. 1 plus, this is cos of 0. You are supposed to know by heart that cos of 0, I have substituted x as 0 here. You are supposed to know by heart that cos of 0 is 1. So if I use this formula, this is going to be equal to 1 into 1 upon 1 plus 1, 1 upon 2. That's how you would do a sum if you have cos. So whenever you have any other trigo ratio other than sine, convert it into sine and solve the sum. That's the basic key to solving trigo in limits. Convert everything to sine. Let's see another sum, guys. Limit of theta tends to 0, 3 theta plus 4 sin theta upon 5 theta cos theta minus 6 tan theta. Now this can be written as limit of theta tends to 0, 3 theta plus 4 sin theta upon 5 theta cos theta minus 6 tan theta can be written as sin theta upon cos theta. People see the way I'm writing this. Tan theta can be written as sin theta upon cos theta. Divide numerator and denominator by theta. I'm going to divide every term by theta. I'm going to divide every term by theta. So theta and theta gets cancelled. So this becomes 3, 4. Sin theta upon theta is 1. Theta and theta gets cancelled. 5 into cos of 0 minus 6. Sin theta upon theta is 1. 1 upon cos of 0. Cos of 0, as I already told you, is 1. So this is 5 into 1, so which I'm going to write as 5, minus 6 upon 1, which I'm going to write as 6. So this is 7 upon minus 1, answer is minus 7. Right? Simple. Let's move on ahead, people. Remember, any trigo ratio you get, you convert it into sine and then solve the sum. Right? Let's see another sum. Limit of theta tends to 0. Cosec theta minus cot theta upon theta. Excuse me. Any trigo ratio that you get, you convert it into sin theta. How do you do this? This can be written as limit of theta tends to 0. Cosec theta can be written as 1 upon sin theta. Cot theta can be written as cos theta upon sin theta upon theta. Limit of theta tends to 0. I could take sin theta as my common denominator, so I get 1 minus cos theta. Sin theta is the common denominator which comes down in the denominator, so you will get this as theta sin theta. Now since you have 1 minus cos theta, as I told you, either you can use submultiple or you could rationalize. We are going to rationalize. 1 plus cos theta upon 1 plus cos theta. Limit of theta tends to 0, a minus b, a plus b. So this is going to be 1 minus cos square theta upon theta sin theta 1 plus cos theta. 1 minus cos square theta, limit of theta tends to 0. 1 minus cos square theta is sin square theta upon theta sin theta 1 plus cos theta. Sin theta and square gets cancelled. This can be written as limit of theta tends to 0, sin theta upon theta 1 upon 1 plus cos theta. Sin theta upon theta is 1, 1 upon 1 plus cos of 0 is 1. By now you should know this. So this is 1 upon 2. Let's see another sum, guys. Limit of x tends to 0, 1 minus cos 2x upon cos 2x minus cos 8x. Let's see this. Limit of x tends to 0. Now since there is addition or subtraction between trigo ratios, you have to use factorization here. Now 1 minus cos 2x, I could have used multiple formulas here, but I prefer rationalizing. Cos minus cos, factorization formula. Cos minus cos is minus 2 sin sine. So this is minus 2 sine 2x plus 8x upon 2 sine 2x minus 8x upon 2. Rationalize the numerator. 1 plus cos 2x upon 1 plus cos 2x. Those of you who are not very familiar with your defactorization formula, I will write the formula here. I am using the formula cos c minus cos d is minus 2 sin c plus d by 2 sin c minus d by 2. This is the formula that I use, defactorization formula. Now let's see this. Limit of x tends to 0, a minus b, a plus b, a square minus b square upon, this is minus 2 sine 10x upon 2, 5x sine minus 6x upon 2, minus 3x 1 plus cos 2x. Right? We have another formula, people, which says, if you're familiar with your trigo basics, sine of minus theta is minus sine theta. That means sine of minus 3x is going to give me minus sine 3x. The minus sign that comes out multiplies with this minus sign to give you plus. So this is going to be limit of x tends to 0. 1 minus cos square theta is sine square theta. This minus sign and this minus sign I just explained to you, multiply to give you plus. Sine 5x, sine 3x, 1 plus cos 2x. Now this can be written as limit of x tends to 0, sine 2x the whole square upon 2 sine 5x sine 3x 1 plus cos 2x. Since there is a x here, whatever is the angle in the numerator, same number in the denominator. That means I am going to divide by x. That means in reality I am dividing by x square. I am dividing the numerator by x square. Hence I will divide the denominator also by x square. Divide by 2. That means I am actually dividing by 4. Multiply by 4. The angle in the numerator and the number in the denominator has to be same. If this is 5, divide by 5, multiply by 5. Divide by 3, multiply by 3. Right? So this is going to give you sine theta upon theta is 1 into 4 upon 2 into 1 into 5 into 1 into 3. 1 plus cos of 0 is 1. So this is going to give you 4 upon, I could cancel this, so that will leave me with 2. 2 upon 15 into 2. So answer is 1 upon 50. Fine, do we get this? Let's move on to the next sum, people. Limit of x tends to a, sin x minus sin a upon root x minus root a. Right? Now again I will have to use limit of x tends to a. I'll have to use a factorization formula. Sin minus sin is 2 cos sin. So this can be written as 2 cos x plus a by 2 sin x minus a by 2. I'm using the factorization formula, divided by root x plus minus root a. Rationalize the denominator, root x plus root a, root x plus root a. I will write the formula for your benefit. I'm using the factorization formula. Sin minus sin is 2 cos sin. Right? That was the formula that I have used. Now this can be written as limit of x tends to a, 2 cos x plus a by 2 sin x minus a by 2 into root x plus root a. Now in the denominator, a minus b, a plus b, which is going to give you a square minus b square. This can be written as limit of x tends to a, 2 cos x plus a by 2 sin x minus a by 2 root x plus root a upon. Now since the whole thing is divide, I can write the divide for any one term. Square root cancel, square root cancel. So that will give me x minus a. Divide by 2, multiply by 2. This 2 and this 2 gets cancelled. Right? So now substitute the values. Since I am using the formula, I will substitute the values. This is going to be cos a plus a by 2 Sin theta upon theta is 1 root a plus root a, right? Now this is cos 2a upon 2, which is cos a. Root a plus root a is 2 root a. So your answer is going to be 2 root a cos a. Fine. Let's move on to the next one, guys. Limit of x tends to 0 sin mx degrees divided by sin nx. Right? Now you have to make sure that all the formulas that you are applying in Trigo have to be on the basis of the angle has to be in radians. The angle cannot be in degrees. Since here the angle is in degrees, you have to convert this into radians. How do I convert this into radians? By multiplying by pi and dividing by 180. So this is going to be sin pi mx by 180. What have I done here, people? I have converted from degrees to radians. To convert from degrees to radians, this is what I did. Divided by sin nx. Divide numerator by x, divide denominator by x. Divide numerator by pi m by 180. Multiply numerator by pi m by 180. Why did I do this? So that I can have the same angle and the number in the numerator and denominator. Same logic here, divide by n, multiply by n. Sin theta upon theta is 1 into pi m by 180. Sin theta upon theta is 1 upon n. Hence your answer is pi by 180 m upon n. Right? The key thing here was to convert the degrees into radians, because all formulas are possible only when your angle is in radians. Right? Let's move on to the next one, guys. Limit of x tends to 0 sin x plus a plus sin a minus x minus 2 sin a upon x sin x. Okay, nice sum. Let's see how do we do this. You use factorization formula. Limit of x tends to 0, sin plus sin, 2 sin cos. So 2 sin x plus a minus x by 2 cos x plus a minus a plus x by 2 minus 2 sin a. I leave it as it is. Denominator I am going to leave it as it is. X sin x. I will write the formula for your benefit. The formula that I use factorization formula. I use the formula sin c plus sin d. Sin plus sin is 2 sin cos. C plus d by 2 cos c minus d by 2. Right? Let's see this. This can be written as limit of x tends to 0 to sin. Now, plus x minus x gets cancelled. 2a upon 2 is sin a cos. Plus a minus a gets cancelled. 2x upon 2 is x minus 2 sin a upon x sin x. This can be written as limit of x tends to 0. Here, this is a very important step. See what I am doing here. I am going to take minus 2 sin a common here. Instead of just taking 2 sin a common, I am taking minus 2 sin a common. As a result, 1 remains from here, and since I have taken minus sign common, the sign will reverse here. This will become minus cos x upon x sin x. Since I have 1 minus cos x, I will rationalize this. So let's rationalize this, people. 1 plus cos x upon 1 plus cos x. This is limit of x tends to 0 minus 2 sin a minus b, a plus b. 1 minus cos square x, which I am directly writing as sin square x, upon x sin x 1 plus cos x. Sin x and square gets cancelled. So this is going to be limit of x tends to 0 minus 2 sin a sin x upon x 1 upon 1 plus cos x. I am just rearranging the terms. Minus 2 sin a as it is, sin x upon x, and this term separately here. Since I have the formula, I can substitute. This is minus 2 sin a sin x upon x is 1 into 1 upon 1 plus cos of 0 is 1. So answer will be minus sin a. Fine, do we get this thing here? This finishes trigo part 1 where the limit of x tends to 0. Next lecture we do trigo part 2 where the limit of x does not tend to 0. Thank you.